Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. This is the last module where we will discuss certain case studies and a few advanced topics. So, learning objectives today will be the recapitulation of the basic cloud, and we will look at a few case studies followed by a few advanced topics that perhaps will help understand cloud better, followed by summary. So, these are the technologies that we have been talking about, the distributed systems, parallel computing, and as enabling technologies we said virtualization and service oriented architecture. As dependent technologies we talked about peer to peer computing, and we looked at this cloud computing and we said that there are a set of resources that are being used by cloud, which will be the storage and the networking resources and the software. There will be the overall infrastructure which will be distributed, which will be an autonomous system and which will be virtualized. There is a set of deployment models, and we discussed the three main models identified by NIST, which is the software as a service, platform as a service and infrastructure as a service. We looked at the deployment models. Essentially there are four deployment models: a public cloud, a private cloud, a community cloud and hybrid cloud, and we looked at the various defining attributes of cloud which cloud has preserved. Now, let us look at how these things actually help people in realizing or in adopting cloud. So, here is our example. First example, Autorun is a manufacturing company which manufactures vehicle parts. They are a small company, they are not a very large company, having about 20-25 lakhs of their turnover. Now, and they do not have IT infrastructure in their organization. They would use telephones to talk to their customers, etc. But now arrival of this company has come, which has been using a software based manufacturing, and that is giving them an edge. But the Autorun company is too small, they cannot have an IT wing, they cannot create an overall environment of IT environment and use email and use this software, etc. So, what will be the possibility for Autorun? They will go for a SaaS cloud. How they will go for a SaaS cloud? This is the largest cloud market, and all the applications will be delivered through web. So, the Autorun company does not have to do anything because it will be managed by third party vendors, and they just need to have thin clients at their end in their organization. So, whatever desktops they have already been having, using that they can manage, or they need to buy a few desktops. So, they will subscribe to email, and therefore, the users are free from any additional cost. So, therefore, Autorun will go to a third party vendor, will subscribe to email, will go to the same vendor perhaps or a different vendor, will subscribe to the particular software that is required by Autorun, and they will manage without actually incurring a large cost into their IT investment. In our second case study, we will look at a DEFCO fictitious company which has already running legacy applications. So, they have their dedicated hardware, they are already an IT enabled company which have been using their hardware, dedicated hardware computers to run their specific applications. These applications are legacy applications that have been developed by someone, and they may not even know who have developed it, but they have been using this these many legacy applications. The complication here is that DEFCO needs different languages and OS support for their platforms. It is very difficult to manage the so many hardware, and as things progress, what's happening is DEFCO's machines are becoming slower and older, they need more maintenance, and DEFCO is not able to manage. So, what will DEFCO do? DEFCO will go for a PaaS cloud. How this will solve their problem? A PaaS cloud has to be polyglot. A polyglot PaaS cloud supports various languages and various platforms. So, if they choose a vendor appropriately, that vendor must provide that polyglot PaaS, and they should be able to handle the legacy applications that the company DEFCO is running. So, the focus is on the operations. They have to choose the PaaS carefully, which will support their multiple legacy applications to be run. So, operation capability of the PaaS service provider is a must, but once they have identified that, they are good to go. They can deploy most of their legacy applications into the cloud, and they can get rid of the hardware problems. But in this particular case, DEFCO's case, the problem will not be completely resolved. There will still be certain problems. First problem is that many of these applications may not be run in a PaaS environment. Why? Because if they require very special hardware that may not be offered by a PaaS, the codes, even a little bit of change in the code to run in a different environment may be required, but there may be many applications where such changes cannot be tolerated, because the code may not at all be available with DEFCO. It could be created by someone who has left the organization, or it could have been created by an organization for DEFCO who have gone off business. So, the solution may not be complete for DEFCO, but a PaaS, a polyglot PaaS is the solution. In a third case study, we will look at an organization called XYZ. They work on government projects. Now, they are interacting with another organization called ABC. They are both developers. They need a Python platform and a versioning system. Now, when two companies try to collaborate with each other, what do they do? How do they collaborate with each other? They need the application to be scalable, so that as things grow, they can provide more resources. They need the system to be highly available, but the developers do not need to waste so much of resources or invest into so much of resources to make it a highly available, highly scalable cloud. So, here is what they need. They need to develop, and then they need to deploy, and then they need to test. If something goes wrong, they need to modify, plus they need a versioning control, which version has been generated by what they need. What is the solution? The solution lies in a PaaS community cloud. What they will do? Here is what they will do. Here is our XYZ developers, and here is our ABC developers. Rather than running around between these two companies to develop, they simply borrow some platform in a PaaS community cloud, and then they collaborate through this PaaS community cloud. They will do their development work. They will have some offline component, and they will have some online component. Why we need a community cloud here, and why not a normal PaaS public cloud? Because this is secret work, confidential work, and in a public cloud they do not want to do it. So, they create one PaaS community cloud and do it. So, their develop, test and deploy kind of mechanism will work like this. In a fourth case study, we look at a bank, and this bank has many infrastructure. They already have a private cloud installed in their organization, inside their organization. But the problem of this bank is that they are growing at a rate, and they cannot cope with, their private cloud cannot cope with the growth rate that is happening. So, what is their solution? Their problem is a little bit more crucial. They do not need all the time an additional resource. Only at some point in time, when there is a big rush, they need additional resource and additional help. So, at the same time, this being a bank, they have confidential information, they cannot put all their information into the cloud. So, what is their solution? Their solution is a hybrid kind of cloud. So, what will they do? This is the bank, and so they have their own private cloud which they have developed in house, and they store all their confidential information in this private cloud, and they interact with it. Now, they will interact with the public cloud only at a cloud burst kind of situation, when there will be a cloud burst situation, additional demand, and they will store their non-confidential data in the public cloud, and they will store their confidential data in the private cloud. Only when they need to access the public cloud, they will use the public cloud, otherwise they will work with their own private cloud. So, this is what they will use. Now, last but not the least is our SOMCORP organization, which is which have already a private IaaS cloud set up in Chennai. They have a proper private cloud, and they have they do not have any problem. They were happily keeping their customers, giving their customers all the services. But during Varta, one severe storm in Chennai, their data center got damaged, and they could not bring the data center up for days on. Therefore, what they have in their hands are unhappy clients complaining about it, and one particular client during the next renewal refused to continue with SOMCORP, saying that they are not reliable. So, they are vulnerable to catastrophic events, and what guarantee can they give that there will not be another similar problem. So, how do they make changes? What they need is, they need high availability and they need disaster recovery system. So, disaster recovery system consists of creating a geo-redundant setup, another data center in a different geographic location, so that any disaster happening to the existing data center can be taken up by this. But setting up an identical data center requires investing that much, and this is a 2 times capital expenditure, twice the capex and the opex also, because all the operations have to be running in the other data center. So, it is not feasible for SOMCORP. So, what is the solution? Again, the solution is a hybrid DR cloud. So, this is what SOMCORP will do. SOMCORP will continue having their own IaaS cloud and continuing working with that cloud. SOMCORP will also store their data in a public cloud. They will not run any instances, but they will continue, they will store their data. Now, in case of any disaster where their private cloud gets affected, they will then spin up some instances in the public cloud, and they will use that as a public IaaS cloud. So far they were using it as storage, now they will use the virtual machines and they will start using it. When the recovery process of their original cloud becomes all right, they will move back to working only with their own cloud, and they will move back to storing the data in the public cloud. So, SOMCORP used a hybrid cloud, only going to the public cloud as and when required in a disaster scenario. This is called a warm disaster recovery scenario. So, let us look at certain advanced topics in cloud. Cloud interoperability is ability to interact or communicate with other clouds across vendors. This In absence of such interoperability, what happens is an end user is not able to move their data and their services from one cloud to the next cloud. Migration of a service is not possible, migrating a virtual machine is not possible, even taking the data out of a service provider and going to the other service provider is not possible. So, how this can be facilitated? This can be facilitated by a proper cloud interoperability. So, interoperability is the ability to communicate and to work, coordinate with across the systems, cloud systems. So, they should be able to take their services and their virtual machines across the boundaries of cloud. This is achieved by making their application and their resources separate, and there have been many attempts in doing interoperability. We will discuss one such attempt. It typically depends on the degree of using open and established standards. So, standards play a very important role in ensuring interoperability. So, what are the advantages of interoperability? The obvious advantage is that the application can be run anywhere. Effectively, it deploys the solution of a single service provider, customizes the services and offers openness, thereby incorporating portability into the service. So, what are the interoperability services that we can give? We can give VM migration if services are interoperable. We can do better data management and migration data. Security can be improved by proper interoperability, improve performance of every cloud as well as the QoS, service accuracy in terms of taking the service nearer to the user, and such stuff can be done better. Standard APIs will be promoted and open interfaces will be given, and the best part of interoperability is it will promote cloud federation. So, one such effort is open virtualization format, where it gives a packaging mechanism. This OVF is largely used by many organizations. It creates a packaging standard for deployment of virtual machines in different platforms. So, across platforms it can be it gives a packaging mechanism by which across platforms virtual machines can be deployed. Typically the images will be taken and will be given to the other platforms. Many organizations, Dell, HP, IBM, Microsoft, VMware, Zen, they are all part of this OVF effort. Now, let us talk about cloud federation. Federation is reassigning some part to another part. So, this could be any part of their resources, and if interoperability is present, only then a federation is possible. So, essentially it is creating an overall organization with the help of so many clouds underneath. So, I will have so many clouds, and each cloud will be interoperably using the other clouds services. So, as the founder and CTO of Anomaly Inc. said, cloud federation manages consistency and access control when two or more independent geographically distinct clouds share either authentication, files, computing resources, command and control of access to storage resources. Two terms are very popularly used. One is called intercloud, another is called federation cloud. These are more or less the same meaning and can be used interchangeably. So, we can, from the service provider's perspective, there may be some resources that are required urgently to fulfill some requirement of an user, and that can be obtained from another service provider. Therefore, the new request that requires additional resource that is not currently available can be obtained from the other cloud provider. If I have some resource and the resource is idle, it is not being used currently by any of my clients, then I can rent that resource out, thereby making my resources better utilized. This way all the cloud service providers will actually benefit by having better, more profit and assured use of resources. SLA violations will be less because no cloud provider will need to say no to a request, thereby they will increase their customer base. For the consumers, these are all advantages for the service providers. For the consumers, the large advantage is the vendor lock-in will be resolved. There are various federation projects that are going on. Bonfire, Reservoir, Intercloud is the name of a project, Contrail. These are ongoing projects that for federated cloud. Now, the third concept is called green cloud computing. Data centers use massive electricity to power the servers, to ensure all the devices are working, and then to cool the servers also they consume electricity. So, data centers are definitely not environmental friendly. They generate a large amount of heat. They have a very large carbon footprint. In fact, in a survey it has been observed that all the data centers put together in the world, they have a carbon emission same as 2 countries put together, Argentina and the Netherlands, which is a very important aspect of cloud computing. So, a green cloud tries to promote less usage of power. How? Efficient processing and better utilization of resources. So many servers are not required, create a federation and therefore use less resources, thereby by doing all these minimize consumption. This is definitely a very important and required part for cloud computing to survive. The last concept which is the IoT, Internet of Things. Nowadays it is called Internet of Everything. These are all the devices that are connected in using network. These are all the smart devices, our smart TVs and phones and our washing machine and everything that we can connect. These are all connected and they send data, they communicate with each other and they send data, and thereby they will create a smart environment. Gartner, who is a very important organization, they predict that by 2020 about 20 billion devices will be used in an Internet of Things. But what about the data that we collect? If there are 20 billion devices, who has the capability to collate so much of data and assimilate something? So, this is where we have. So, this data has to be collected, collated, integrated with other applications and analyzed. Cloud is the best solution for it. In fact, there has been predictions that with the growth of IoT, cloud will grow more and more. So, already there is a lot of effort that is present. Oracle offers a IoT cloud, Salesforce.com offers an IoT cloud, and so on. There are many other organizations who are also putting their efforts in the IoT space and combining IoT with cloud. So, this summary is the overall summary for the whole course. We looked at cloud as a large distributed system, and we looked at various aspects of distributed system to see how these aspects fit in the cloud. We looked at the time mechanism, the time synchronization of distributed systems rampantly used in a cloud environment. We looked at the vector clocks, which are very integral part of a cloud environment. We looked at communication, RPC. There are many big giants like AWS who depend on primitive native, their own indigenous RPC mechanism to communicate across their entities. Then in distributed environment, we further looked at election. We saw that there are various tools who depend on election to choose one among a set of peers in the environment. We further looked at mutual exclusion in a distributed environment, which again is a very important aspect in cloud environment, because data has to be used or a service has to be used in a mutually exclusive manner, and there has to be mechanisms to ensure mutual exclusion in cloud. We looked at transactions in detail, replication in detail, and perhaps the most important part of cloud is how to interact with the clients, multiple clients at the same time. It could be the transactions, it could be other mechanisms that we looked at later on, and replication is perhaps the major mantra of cloud computing to survive in the in this world. So, we looked at replication at in detail in a distributed environment. Then we looked at virtualization. Virtualization is the central concept in cloud computing, because virtualization promotes resource sharing, and resource sharing is what cloud does the best and cloud is famous for. So, we looked at how hardware resource sharing has been done, how software resource sharing, containerization can be used in a cloud environment. And of course, network virtualization, by which we have virtualized the whole physical network and using that in a cloud data center, so that the network is utilized properly, and storage virtualization, by which we can utilize the storage in a better manner. We looked at web services. Cloud uses, we looked at two types of web services, SOAP based and RESTful, but largely cloud uses a RESTful web services, although again AWS, Amazon AWS and many other cloud services do offer both RESTful as well as SOAP based web services. We looked at P2P architecture. In a P2P architecture, we saw that how a P2P architecture is created, and our whole of our cloud storage is dependent on the typical of P2P architecture. Further, we looked at cloud basic architecture. We saw how a cloud is surviving using what kind of architecture. We looked at the different services of cloud. We saw SaaS, PaaS, IaaS as our example services. Later on, during security, we looked at security as a service. During networking, we looked at network as a service. We talked about mechanisms like Paxos, that is very popularly used in cloud environment. We looked at cloud storage, we looked at cloud networking, and we looked at cloud security. And finally, we looked at a case study where we saw a very popular cloud middleware called OpenStack, and we looked at Eucalyptus as well. This brings us to the completion of this particular course called cloud computing. These are the references for this particular module. Thank you.